Um, in this video, I'm going to show you what a machine learning model looks like. And this is again for absolute beginners. So the dataset you are looking at on your screen is a sample dataset randomly generated for different houses. So for example, the second row represents the one house with 3 bedrooms, 2 bathrooms, and it has got solar panels. The last column represents the price of the house. The second row represent another house. This house has got 6 bedrooms. It has got 3 bathrooms. Its land size is 573 square meters. It doesn't have solar panels, and its price is approximately 1.4 million. Now, the columns highlighted in yellow, these columns are known as independent variables because the hypothesis is that these variables do not depend on anything else. The last column, which is the price, is known as the dependent variable or the target variable for machine learning model purposes. And the hypothesis is that the last column, which is the price, which is a dependent variable, can be predicted using the other variables which are independent variables. So effectively, perhaps there's a mathematical formula which can predict the price using the variables highlighted in yellow. And that is what a machine learning model is. Because the value that we are trying to predict here is numeric, so price can have values like 1 mil, 2 mil, whatever. Those machine learning models are called as regression models. So I'm going to show you a very simple regression model. So on your screen you can see a very simple regression model highlighted in yellow and another regression model which is highlighted in blue. So the first regression model is basically saying that the price is equal to land size multiplied by 1500. The second machine learning model says that the price is equal to land size times 2000. Now these are not real they are not the true mathematical formula that will define the price, but these are just an example of what a machine learning model will look like. A real machine learning model, the mathematical formula behind a real machine learning model will be more complicated in the sense that at the moment the price is just dependent on land size, but in reality the formula will have values for number of bedrooms, a number of bathrooms. So maybe the real formula, which we don't know yet, may look like land size times 1500, then bedrooms times 500, so on and so forth. Okay. Now, but for the purpose of demonstration, we will just assume that the machine learning model, the simplest machine learning model, looks like this, which is land size times 1500. So I'm going to predict the price using that machine learning model, which is price is equals to the land size times 1500. So what would be the predicted price then? So I'm saying predict price using model 1. All right. Okay, and the model 1 is, I'm going to write the formula. Model 1 will be equal to E2 times 1500. Okay, and then I'm going to extend it till end. So now this column, the column J, is the price which is predicted by the model 1, and model 1 is very simple, as you can see. Okay, I'm just going to hide this column so that you can see the full display. Now, as you would have noticed that this model is not giving you the accurate price. In fact, most machine learning model will never give you the accurate price. There will be an error. So let's figure out what the error in this model 1 is. All right, what is the error in model 1? All right, model 1. Okay, so the error in model 1 would be For the first house, the error would be the actual price, which is the column in green, and the predicted price, which would be the column in white, which is a J column. So I'll simply say I2 minus J2. So I2 minus, sorry, not I1, it's I2. So I2 minus J2. So this is the error in the model 1, and I can extend this error to all houses, and you can see that for the first house the model is very wrong. It's way off, and it's off by almost 576,000. And in the last house the model is not that off, but it's still off. It's still giving us a very incorrect value, which is 300. The error is 392,000. Okay, so that's the error in model 1. Now in reality, what the aim of the machine learning model, the whatever task you do, is basically to find out what is the true mathematical formula behind the data set. Okay, the true mathematical formula is unknown, and the aim of the regression model is to find the true mathematical formula. So what we will do is, let's say that we create a new model, let's say model 2, and here we pretend that the price would be the land size times 2000. Okay, so that's my model 2. So let me just figure out what would be the price predicted by model 2, and then we will compare which model is better. Is model 1 better than model 2, or is model 1 worse than model 2? In reality, when you're doing machine learning task, you will come up with quite a few models, and then you will compare the models and choose the model which performs best. Okay, so for the model 2, again I'll use the predicted, I'll use the mathematical formula, and the formula is again the simple one, which is the price of the house is, and that's the assumption, the price of the house is E2 times 2000. All right, and then I will extend this formula till the end, and then I will again try to figure out the error in model 2. All right, and then I'll try to figure out what is the error in model 2, how wrong is the model 2, and again the formula would be the actual price, which is the price in green, minus the predicted price. So the model 2 would be, the error in model 2 would be the actual price, which is I2, minus the predicted price, which is L2. Okay, and then I will extend this formula for all the houses, and as you can see, for the first house, the model 1, the error in the model 1 was 576,000, but the error in model 2 is only 150,000. For the second house, the error in model 1 was 586,000. The error in model 2 was 300,000. So both models are giving us incorrect values, but one is better than the other. If we wanted to figure out overall which model is better, is model 1 better than model 2, or it's the other way around, then what we can do is we can calculate the total error. So for example, if I sum all the errors, okay, if I sum all the errors, this one, and then I do the same thing for the total error in your model 2, okay, and I'll just try to put that in millions, so that the you can see the value in millions. Um, so I'm going to format these in millions. So I'll say okay. So I'll just highlight those two values in red. Okay, so the values highlighted in red at the bottom, you can see that the overall, the error in predicting the price using model 1 is approximately, overall it's 10.7 million. The error in using the model 2 is just 3.7 million. So between model 1 and model 2 is better than the model 1. So what that is telling you is that the model 2 formula, which is the price of the house's land size times 2000, is better. That mathematical formula is better than the model 1 mathematical formula, which is price equals land size times 1500. Again, in reality, this formula would be a more complicated, but nonetheless, it would be a mathematical formula which would include different variables, some numbers, and so on and so forth. So, in a nutshell, what I have shown you is how what a machine learning regression model would look like, which is just a simple mathematical formula. How would you calculate the error in predicting a variable using a machine learning regression model, and how would you compare two different models? Okay, thank you very much for listening to the video.